Good morning, everyone. Today's topic is our diode. We will discuss about some numericals which is based on our diode. So, in previous lectures, we have already discussed about diode. That what is diode? Diode is a semiconductor device which is used for rectification. So, rectification means that it will convert from DC to AC to DC. So, if you want the output which is uncontrolled, then you can use diode for rectification. And there are so many type of diodes which we have studied in our last lectures. Now we will discuss about some numerical problems which is based on diode. So the course objective of this subject that to introduce the students to the basic theory of power semiconductor devices and passive components and their practical applications in power electronics, and to familiarize with the students to the principle of operation, design, and synthesis of different and power conversion circuits and their applications, and to provide strong foundation for further study of power electronic circuits and systems. So the outcome which is I'm expecting from the student, that student will be able to understand the uh, different type of diodes, the working of diode, and how a diode is used for rectification. So student will be able to solve some numerical problems which is based on the principle of diode and its working. So diode basically a PN junction. One layer is P and another layer is your N. When diode is when it has two terminal, anode and cathode. When anode is connected to the positive terminal and cathode is connected to your negative terminal, so diode will be in reverse forward biasing. When anode is negative and cathode is positive, diode will be in your um, reverse biasing, and diode will conduct only in forward direction when your anode is positive with respect to cathode. In that case, the current will start to flow through the diode. Now, the second thing, that diode will not conduct in the reverse direction. Okay, so there will be some microampere current which will flow in reverse direction, which is called your leakage current. And for silicon and germanium, the diode basically the semiconductor devices or semiconductor material which is used for construction of diode is your silicon and germanium. So in this lecture, we are going to discuss about some few numericals which is based on your diode and its VI characteristic. And after solving these problems, you would be able to understand that what is diode, how it works, what are its voltage and current values, and how much resistance we required for a particular circuit, and so many things. So let's start with first numerical. So the question is given that an AC voltage of peak value 20 volt is connected in series with a silicon diode and load resistance of 500 ohm. So here is the AC voltage of peak value is given, which is 20 volt, and it is saying that it is connected in series with a silicon diode. So it is connected with your silicon diode and load resistance of 500 ohm. The load which is given is 500 ohm. If the forward resistance of diode is 10 ohm, so forward resistance is also given, which is your 10 ohm. Then what it is asking? It is asking about your peak current through diode, peak output voltage. What will be these values if the diode is assumed to be ideal? So let's come to the solution, that in the question, that the diode has one AC voltage which is connected like this, and the load resistance is your 500 ohm, and the peak input voltage is given, which is your 20 volt. Now, what it is saying that what you have to do, you have to find out the peak current through diode and peak output voltage. So the peak current through diode you require voltage and resistance, and if you want to calculate peak output voltage, then you require current and resistance. So the peak input voltage which is given, that is your 20 volt, and forward resistance, as you can see in the question, that the forward resistance which is your 10 ohm. Forward resistance means when diode is connected in the forward biasing, there is some resistance which is appearing in the circuit due to diode. So that is your forward resistance of diode, which is your 10 ohm, and the load resistance is given RL is equal to 500 ohm. Now the potential barrier voltage V naught, which is your 0.7 volt, which is not given in the question. We are assuming this voltage. Uh, uh, okay. So we are taking barrier voltage is your 0.7 volt. So the diode will conduct during the positive half cycle, because you can see that the peak voltage of your AC voltage is 20 volt. So AC voltage is in supply, so it will have one positive cycle and one negative cycle. When positive cycle comes, then diode will be in your forward biasing, because this terminal will be positive and this terminal will be negative. So diode will be in your forward biasing mode. And the second thing, that diode will not conduct in the reverse direction, because when you apply AC voltage for your negative half wave, this terminal will negative and this terminal will positive. So diode behave like an open circuit and the current will not flow through this diode. So this is the concept about your positive half cycle and negative half cycle, or you can say that the forward biasing and reverse biasing. Now let's come to the diagram, that the forward resistance is given 10 ohm, and the voltage which is appearing when diode is in forward biasing, that is a 0.7 volt, and the load resistance is given 500 ohm. Now it is asking that that what is your peak current through the diode. So you have to find out the current which is flowing through the diode. So let's calculate this peak current by these equations. So you can see the peak current through the diode will occur at the instant when the input voltage reaches its positive peak, which is your 20 volt. So in forward biasing, the voltage drop VF is equal to, if you apply, if you apply KVL, then you will see that 20 minus this voltage and the diode forward current IF into 10 plus IF into 500. So you can easily find out the forward current value. So you have to apply your, you know, uh, forward loop, KVL. You have to apply KVL in this loop. So if we apply KVL in this loop, we will get, suppose this is your Vs supply voltage. So Vs minus V naught and minus If into 10 plus 500 ohm, where If is the current which is flowing through the diode. So what is KVL? KVL is that, the statement of KVL means that the voltage in a loop, the sum of the voltages of each branch in a loop is 0. So this is the loop, and it has 1, 2, and 3 branches which is connected to each other in a series. So the voltage drop across these branches, the sum of voltage across these branches is equal to 0. So 20 minus 0.7 volt into IF into 510 is equal to 0. So you will get this equation. Okay, Vf is equal to V naught plus IF peak into resistance of your diode when diode is conducting forward biasing, and RL is your load resistance. So IP peak is equal to VF minus V naught upon RF plus RL, which is equal to 20 minus 0.7 upon 10 plus 500, which is equal to 37.8 milliamperes. Now, the second thing, then what is your peak output voltage? So, peak output voltage, IP peak into RL is equal to 37.8 milliamperes into 500 ohm is equal to 18.9 volt. Okay. So, you can get the peak output voltage by this equation, because from this equation you got the value of forward peak diode current, which is 37.8 milliampere, and the peak output voltage, which is your 37.8 milliampere into 500. This because this resistance is connected into the load, so uh, this resistance is connected into the load, so the voltage across this resistance will be your output voltage. So you have to multiply the resistance, which is your 500 ohm, into the current which is flowing through this branch. So the current which is flowing through this branch is your IF, and the value of IF is your 37.8 milliampere. So you have to multiply 37.8 milliampere to 500, then you will get the output voltage. Now, this is the practical condition when diode is conducting. Now, we will consider the ideal case when diode has no voltage drop when diode is conducting. So, here we are taking the voltage drop across the diode is equal to 0.7 volt. Now, we will consider that there is no voltage drop across this diode. So, let's start with your ideal case of diode. So in this case, the resistance across the diode will be zero, and the voltage across the diode when diode is conducting is also zero. So that's why we are taking the output voltage V naught is equal to zero, and RF is also equal to zero. So the forward voltage is equal to IF peak into RL, and you will get the forward current or peak current which is flowing through the diode is equal to VF upon RL. So it will be your 20 volt upon 500 ohm, that is your 40 milliamperes, and the peak output voltage will be 20 volts. So you can say that if you compare these two uh, solutions, then you can see that in the practical case, the current which is flowing through the diode is less than the current which is in the ideal case, which is your 40 milliampere, and the peak output voltage, which is your 18.9 volt, and the peak output voltage, which is your 20 volt. So the voltage is also greater than in this case. Now, let's come to the next question. So I think now you are able to understand that how diode is conducting in ideal case and how diode is conducting your practically, and what is the difference between the voltage and current, the current which is flowing through the diode in ideal case and practical case, and what is the voltage which is appearing across your load. Now let's come to the next question, which is find the current through the diode in the circuit shown in figure. Assume the diode to be I. So in the diagram you can see that voltage source, which is your 10 volt, and two resistances are connected, R1 and R2. One resistance has your 50 ohm and another resistance is your 5 ohm. Now a diode is connected in parallel with your R2. So you can see that you have to find out the current which is flowing through the diode. So what you have to do that it means diode is conducting. Okay. So it means that diode will behave like a closed switch. Now you have to apply the Thevenin voltage, Thevenin theorem across this into this circuit. So what is Thevenin theorem? The procedure of Thevenin theorem is this: the branch in which you want to find out the current, that first you have to remove that branch. Then the voltage source, you have to, if there is any voltage and current source, so what you have to you have to remove your voltage source. So you have to short the voltage source and you have to open the current source, and finally you will get the Thevenin resistance. Okay, and after that you have to calculate the Thevenin voltage. So in Thevenin theorem, the finally the total voltage and the Thevenin resistance is connected in series with the load resistance or the diode in which you want to find out the current. Okay, so first you have to apply Thevenin theorem over here. So if you want to find out the current through this diode, first you have to remove this branch. Okay, and you have to short the voltage source. Okay, so you have to short the voltage source. Now, when you short this voltage source and you open this circuit, what is happening? These two resistances coming in parallel. So the total resistance will be the parallel combination of this resistance. So R1, you can find out the resistance by this is Thevenin's resistance, and the resistance at terminals AB with diode removed and battery replaced by a short circuit. So the Thevenin resistance is equal to R1 R2 upon R1 plus R2, and you will get the Thevenin resistance, which is equal to 4.55 ohm. Now next is you have to find out the Thevenin voltage. So what is your Thevenin voltage? First, what you have to do uh, to find out the Thevenin voltage, you have to find out the voltage across this diode. Okay? You have to find out the voltage across this diode. So, if you want to find out the voltage across this diode, you can find out the voltage across this resistance. So, what is happening? Because these both branches are in parallel. So, if you get the voltage across this resistance, which is your R2, you will be able to get the voltage across these terminal, because diode is, we have already removed the diode. Okay, so this is your open circuit branch, open circuit, and there will some voltage which will exist across this branch. So you can easily find out the voltage by applying your voltage division rule. So according to voltage division rule, when two branches are in series combination, okay, and two branches are in your series combination, so if you want to find out the voltage across this branch, so you have to take the resistance of this branch and you have to apply this voltage, and you have to divide the total resistance of the circuit. So you can see here that the voltage across this resistance we can find out by this Thevenin's voltage. So open circuited voltage across AB with diode removed. So R2 upon R1 plus R2 into B is equal to 5 upon 50 plus 5 into 10. You will get 0.909 volt. Now, you can easily find out the Thevenin voltage, and this is your Thevenin resistance. So now you can easily calculate the current through the diode. So the current will be current which is flowing through the diode is equal to the Thevenin voltage 0.909 upon divided by 4.55, which is your Thevenin resistance, and the current through the diode is equal to zero point 0.2 ampere, which is your 200 milliamperes. Okay. Now next question which is given, which is very important, that calculate the current through 48 ohm resistor in the circuit shown in figure. Assume the diode to be of silicon and forward resistance of each diode is 1 ohm. So the forward resistance of the diode is given, that is 1 ohm, and you have to find out the current which is flowing through this diode. Okay. So there is four diodes, D1, D2, D3 and D4. Diode D1 and D2 is connected in anti-parallel. Okay, like this. D3 and D4 is also in anti-parallel. If you see from this diagram that this terminal is positive, the supply voltage terminal is positive and this terminal is negative. So D1 will be in your forward biasing because this terminal is positive and this terminal is negative. So diode will be in reverse, forward biasing like this. D2, D2 because this terminal is positive. So cathode is negative with respect to anode. So diode D2 will be in your reverse biasing. Now let's come to this particular D4. You can see that if this terminal is negative, this terminal is negative, it means that the anode terminal of diode is negative with respect to your cathode terminal. So the you can say this diode will be in reverse biasing. And when you talk about this diode, in this diode, this terminal is negative with respect to this terminal. So this diode will be in your forward biasing. Okay. So what is happening? What is happening? That D1 is in your forward biasing, D3 is also in forward biasing, but D2 and D4 is in reverse biasing. Okay, and you can see that the diode in reverse biasing will not carry any kind of current and it will behave like an open switch. So we can take the equivalent circuit diagram of this circuit. So you can see that this is your 10 volt supply. Okay, and this is your diode D1, D3, D2 and D4, and this is your open circuit. And the you can see that in the question that we are assuming the diode to be of silicon and forward resistance of each diode is 1 ohm. So you are taking 1 ohm resistance here and 1 ohm resistance over here, and D1 and D3 is connecting to each other, and the voltage which is voltage drop across the diode when it is in forward biasing is your 0.7 volt and 0.7 volt for diode D3 also. Now what you have to calculate? Calculate the current which is flowing through the 40 ohm resistance. So let's start with this solution. So diode D1 and D3 are forward biased while diode D2 and D4 are reverse biased. So we can therefore consider the branches containing diode D2 and D4 as open. So replacing diodes D1 and D3 by their equivalent circuits and making the branches containing diode D2 and D4 is open. So we get the circuit shown in figure 3, and as we know, for a silicon diode, the barrier voltage is 0.7 volt. So we have already taken the barrier voltage which is 0.7 volt. Now what can we do? That we can apply a KVL over here. So from negative terminal to positive terminal plus 10 volt. Now the current is flowing in this direction and voltage drop across this is 0.7 volt. So the 10 minus 0.7, and this is your current minus 48 into I1 and minus 0.7. So the 10 minus 0.7 minus 0.7, that is your 8.6 volt. So total circuit resistance you can easily find out that 1 plus 48 plus 1. So this is your 50 ohm, and the current which is flowing through your, know, the resistance which is your 48 ohm is 8.6 upon 50, which is equal to 0.172 amperes. That is your 172 milliamperes. So this is the solution for this circuit, that the current which is flowing through the resistance 48 ohm is your 172 milliamperes. Now, next question is that determine the current I in the circuit which is shown in figure. Assume the diode to be of silicon and forward resistance of diode to be 0. Okay. So the question is that we are taking that the diode is made up of silicon, which is your semiconductor material. So the forward resistance of diode is 0, and there may be some voltage drop. And if you are taking forward resistance of diode is 0, okay, so determine the current in the circuit, which is your R. Okay. So the circuit is given that E1 is equal to 24 volt, and E1 is equal to 24 volt, and the current which is flowing through 2 kilo ohm resistance is your I, and there is two diodes connected, which one is your D1 and another one is your D2, and which is connected in this circuit to each other in anti-parallel, and the voltage battery which is over here is your 4 volt. So both the terminal of this E1 is grounded and the terminal of E2 is also grounded. So we can reconstruct this diagram. Okay, so we can connect this diagram to each other. Now let's come to the solution. The If you see that this terminal is positive, so diode D1 will be in your forward biasing, and this terminal is your negative. Okay, ground is connected to ground. So the voltage drop across this terminal is less than the voltage across this terminal. So diode D2 will be in your reverse biasing. When a diode is in your reverse biasing, that it will not conduct or it will behave like a open circuit. We have already discussed that when diode is in reverse bias, because it has one p layer and one n layer, when you apply the negative voltage across the p layer and you apply positive voltage at the terminal of your n layer, so what is happening, p is having more holes as compared to electrons, and in n layer there are more electrons as compared to hole. So what is happening, the hole will try to attract your negative terminal because it is connected to the negative terminal, and the electrons of n layer will try to come to the positive terminal. So what is happening, that when it is connected to the positive terminal of when P is connected to your negative terminal of the battery, so they will try to attract your negative terminal. And when negative terminal of positive terminal of battery is connected to N layer, then in that case also electron will try to attract your positive terminal. So what is happening? The depletion layer is increasing. That's why there is no movement of holes and electrons into the p-n junction. So there will be no current when diode is in reverse biasing. So that's why we are taking this diode as an open circuit now, as an open circuit. So what is happening? That the diode is in your open circuit. One diode is conducting. So the voltage across the diode is your 0.7 volt, and this diode is in your behaving like an open circuit. So what is happening, that So the condition of the problem suggests that the diode D1 is forward biased and the diode D2 is in reverse biasing. So we can therefore consider the branch containing diode D2 as your open circuit. So further diode D1 can be replaced by its simplified equivalent circuit. So you can replace this. You can see that we are not considering this branch. So it is a loop in which you can apply KVL. So when you apply KVL from this side, you will get this that 24 volt minus 2 kilo ohm into I minus 0.7 volt and minus 4 volt. Okay, that is equal to 0. By solving this equation, you can easily find out the current I which is flowing through this diode. Okay, so you can see that I is equal to E1 minus E2 minus P naught upon R, which is equal to 24 minus 4 minus 0.7 divided by 2 kilo ohm, which is equal to 19.3 upon 2 kilo ohm, which is equal to 9.65 milliamp. So this is the solution of this numerical. Okay, I think now you are very much clear about the small things, which is your forward biasing of diode, reverse biasing of diode, current of what current is flowing through the diode. So you are clear about this uh, numericals or basics of your diode. Now let's come to the next question. So the question is that find the voltage VA in the circuit shown in figure 5 and use simplified model. So you can see it is very interesting question because both semiconductor material we are taking over here. So the one diode is made up by silicon and one diode is made up of germanium. So you know the voltage drop when diode is conducting, like see 0.7 volt in the case of your silicon and it is 0.3 volt in the case of your germanium. So you can see that um, the terminal voltage of this is your 20 volt and two diodes are connected in parallel. One is made up by silicon, one is your germanium, and there is 3 ohm resistance which is connected to the ground. And the voltage at this point is your voltage across this point is your VA. Now, what the question is saying that find the voltage VA in the circuit shown in figure and use simplified model. So the voltage is VA. So you have to find out this voltage VA. Now you can see that it appears that the applied voltage is switched on, the diode will turn on, but that is not so. When voltage is applied, germanium diode will turn on first and the level of 0.3 volt is maintained across the parallel circuit. Why it is happening? Because the forward biasing voltage across this germanium is your 0.3 volt and which is for silicon that is your 0.7 volt. So the voltage drop is across the germanium is less than to your silicon. So zero point 0.3 is for germanium, this is your 0.3 volt. So what is happening when this is 0.3 volt? So first, when you apply the voltage across this terminal, so as you apply supply voltage, because this voltage is high as compared to your this voltage, so this diode will be turned on. Both are in parallel. Okay, both are in parallel. So the current will flow through this circuit. And you know when two branches are in parallel, the voltage across those branches will be same. So the less voltage drop diode will turn on first. So it appears that when the applied voltage is switched on, both the diodes will turn on, but that is not so. So when the voltage is applied, germanium diode V naught is equal to 0.3 volt will turn on first, and the level of 0.3 is maintained across the parallel circuits. So the silicon diode never gets the opportunity to have 0.7 volt across it, and therefore remains in open circuit state. You can see that the voltage which is across this is your open circuit voltage. Now you have to find out the voltage across this branch at this terminal. Okay, so you can easily calculate the voltage across this terminal. That is your supply voltage. So 20 minus this voltage will be appearing across this at this point. So the voltage at point A is equal to 20 minus 0.3 volt, which is equal to 19.7 volt. So by solving these questions, you are easily understand or solve the problems which is based on diode. And this is very simple problems, but very important to solve very complicated circuits. So for two things you have to remember, few things you have to remember. One is that when anode terminal is positive with respect to cathode, in the case of diode, the diode will be in your forward biasing, and there will be some current which will flow through the diode. And if it is made up of silicon, which is your semiconductor material, the voltage drop across the diode will be your 0.7 volt in the case of silicon. If, if the voltage across, if the voltage across the, you know, if diode is made up of germanium, then in the forward biasing case, the voltage drop across the diode will be on 0.3 volt. Okay, so this is the basically this is the basic thing which you have to remember. And second thing is that the diode will be in forward biasing when anode is positive with respect to cathode, and in that case the current will flow through the diode. But when anode is negative with respect to cathode, that the current will not flow through the diode. So diode will be in your reverse biasing. In the case of reverse biasing, there is some very small current which will flow, that is called your leakage current. So it is very, few milliampere or microamperes. So we will not consider this current, and diode is in reverse biasing. So in the reverse case, the diode will behave like a open switch. Open switch means that there is no current through the diode. Now, these are some basic questions which is based on this lecture, or the basics of diode. So you can see that the first question is, a crystal diode has one p-n junction, two p-n junction. As you know, the diode is made up of one p layer and one another is your n layer. So diode has one p-n junction. Now, the second question is that a crystal diode has forward resistance of the order of, uh, actually, diode is in forward biasing, that there will be some very small current. But if you talk about a crystal diode, that there will be uh, forward resistance, okay, which is your in ohm. Now, the third question is, if the arrow of crystal diode symbol is positive with respect to bar. Arrow means arrow means that this is your arrow and this is your bar. So it is saying, if the arrow of crystal diode symbol is positive with respect to bar, then the diode is in your forward, because anode is positive with respect to. So these are some few questions. You can easily understand diode and basics of diode. And the reference for these question is your NPTEL. You can go through your and some books which is very good for diode. For example, your P.S. Bimra, M.H. Rashid, and Rajiv Tiwari. Uh, so the you can easily understand the basics of diode. Thank you.